Hello, and welcome to the Android Application Development course offered by Simplilearn. In this course, we will learn how to develop Android applications and use different controls. We will also see how to publish your own application in Google Play. Having basic knowledge of Java would be an added advantage for this course. On completing this course successfully, you will be able to develop and publish an Android application on your own. Let us start with Chapter 1, Introduction to Android Application Development by understanding the objectives. By the end of this lesson, you will be able to explain the architecture of Android operating system, list the components of Android application, describe the activity and life cycle of activity, explain stack of activity, explain service, its use and importance. We will also discuss what broadcast receiver is and why it is used. We will finally move on to discuss content provider and its benefits. In this section, we will discuss the architecture of Android operating system in detail. The architecture of Android operating system is divided into the following sections: Linux kernel, libraries and Android runtime, application framework, and applications. In the next few slides, we will discuss each of these in detail. Let us look at the first of the Android operating system architecture sections, Linux kernel. The Linux 2.6 kernel provides services like security, memory management, process management, network stack, driver model, and power management. It is reliable and also acts as an abstraction layer between the hardware and the rest of the software stack. Next, we will understand libraries. Android includes a set of libraries from C or C++ libraries, like libc and SSL. Some of the common libraries in Android and their functions are as follows. Surface Manager manages access to the display system. SQLite provides a native but powerful database support for Android apps. Media Framework allows playing audio and video files and viewing images. SGL and OpenGL and ES are the most commonly used graphics libraries. FreeType renders bitmap and vector fonts with which you can customize fonts in your apps. SSL, or Secured Socket Layer, offers security during Internet browsing. WebKit helps to integrate Internet browsers in Android applications. After discussing libraries, let us move on to understand Android runtime. Android runtime is divided into two parts, core libraries and DVM. Core libraries provide nearly all the functionalities that are available in the core libraries of the Java programming language. Dalvik Virtual Machine, DVM, is register-based and optimized in such a way that a device can run a number of different instances of DVM with the help of multi-threading so that the application runs very efficiently. Every application runs with its own instance of DVM separately, just as in Linux. Moving on, let us now learn about the application framework. Application framework is a rich set of classes that helps in the faster development of an Android application. It is an open-source development platform. It offers the ability to develop rich as well as innovative applications using the Android. Also, it offers an abstraction to hardware access and manages user interface, UI, and applications resources. In this slide, we will discuss the last of the Android operating system architecture sections, applications. Applications are written in Java programming language. Examples include messaging, calendar, Google Maps, web browser, and music player. UIs, user interfaces of Android applications, can be designed by using programming languages such as Java and XML. With this, we come to the end of our discussion on the architecture of Android operating system. Let us now start with the components of Android application. There are four basic components of an Android application, namely activity, service, broadcast receiver, and content provider. Let us learn about these components in detail in the subsequent slides. In this slide, we will discuss the first component, activity. What is an activity and why do we use it? An activity represents a single screen with UI or window. To create an activity or window, inherit activity class from the Android.app package. Activity class creates a window in which UI can be placed with the method setContentView. While activities are often presented as full-screen windows, they can also be used as floating windows or embedded inside another activity. The onCreate bundle is where you initialize your activity. All activity classes must have a corresponding activity declaration in their packages Android manifest.xml. If we do not register or declare activity in manifest file, the application will crash and will give the message, "Unfortunately stopped." Manifest is a simple XML file which keeps track of all required information about an application, such as version, permissions required, activities, services, broadcast receiver, and content provider. In the next slide, we will discuss the life cycle of an activity. The main functions in the life cycle of an activity are onCreate function, onStart function, onResume function, onPause function, onStop function, onRestart function, onDestroy function. OnCreate is the entry-level function for an activity like the main function in Java. When you run an Android app, only onCreate function will work, whereas onStart function and onResume function will be skipped. To understand other functions of activity lifecycle, let us take an example. Suppose while playing games, you get a call on your Android. The game will be paused. Actually, Android operating system will call onPause function for that game, where the game developer may have written code to pause the game. And when you wish to resume the game, you can resume it from where you stopped before taking the call. This can be done using onResume function. Sometimes, between applications, we hit the home button of the Android device or phone to go back to the home screen. In such cases, onStop function will work and stop your application. Your application will remain in memory. The application is not killed, but is running in the background. When you open the same application again, it will open from where you were before hitting the home button. OnRestart function and OnStart function will work here. And when you press back to exit from the application, OnDestroy function will run. The image of the activity lifecycle is given on the screen. Now let us learn about Activity Stack. The Android environment maintains a stack of all the open activities. For every application, a separate stack is maintained in memory. When an activity is opened, or when we start a new activity, an entry is added to the stack. When an activity is closed, the last entry will be deleted from the stack. In the next slide, we will understand the next component, service. A service is a component that runs in the background to perform long-running operations or work for remote processes. Each service class must have a corresponding service declaration in its package's Android manifest.xml. A service does not provide user interface. Another component, such as an activity, can start the service and let it run or bind it to and interact with it. For example, suppose you have set an alarm for a meeting the next day at 1 p.m. For setting the alarm, you need some user interface. But once you save it, it will scan for the right date and time in the background and will raise the alarm on the respective date and time. To create a service, inherit service class from the Android.app package. Service has three main methods, namely onCreate function, onStart function, and onDestroy function. In this slide, let us look into Broadcast Receiver. Broadcast Receiver listens to broadcast intents. It will receive messages broadcasted by the Android operating system from time to time, and this is why it is called Broadcast Receiver. It must be registered, either in code or within the Android manifest.xml. An intent filter must be used to specify the intents it is listening for. A broadcast receiver can be registered using multiple intent filters. The onReceive function method has to be overridden to perform any operations using Broadcast Receiver. Let us take the same example of the alarm again. You have set an alarm and your phone is dead due to the battery having drained out or some other reason. After restart, would you like to restart the application or wait for it to start automatically? The Android environment broadcasts some messages as it starts. We can receive those messages if we have written Broadcast Receiver and automatically start application or service again. Let us understand more about Content Provider in the next slide. Content Provider is one of the primary building blocks of Android applications that provide content to applications. It encapsulates and provides data to applications through a single interface called Content Resolver. A content provider is only required if the data has to be shared between multiple applications. For example, the contacts data is used by multiple applications and must be stored in a content provider such as WhatsApp or Truecaller, which reads contacts information and lets the user know from whom they are getting a call. This brings us to the end of this topic. In the next few slides, we will understand more about ADT Bundle for Android. ADT Bundle is a set of latest Android SDK, Eclipse, and SDK Manager. In this course, we will use the Google ADT Bundle for developing Android applications. For this, download the latest ADT Bundle from http://developer.android.com. Navigate to Get the SDK and click on Download Eclipse ADT for your operating system. To start developing the Android application, unzip the ADT Bundle. Before you open Eclipse from ADT Bundle, ensure that you have the latest JDK installed on your machine. Let us look into the new topic, Android Virtual Device or Emulator. Android Virtual Device, AVD, or Emulator is a logical device where you can install, run, and test your application on your machine. There is no need to copy the Android binary every time to a physical device. Everything can be emulated on a virtual device or emulator. The only thing that requires a physical device is vibration. To create Android Virtual Device, follow the steps mentioned below. In Eclipse, go to Window, then go to Android Virtual Device Manager. Click New in Android Virtual Device tab to create AVD for the first time. Then enter credentials like AVD, name, select device, front and back camera, RAM, internal storage, and SD card. Keep Hardware Keyboard Present checked. It will allow you to use the keyboard. Then click OK. Finally, to launch AVD, select AVD and click Start and then Launch. Let us discuss a new topic, DDMS in Android. In this slide, we will learn about DDMS. DDMS is the abbreviation for Dalvik Debug Monitor Server. It is used to emulate GPS and other things on emulator. DDMS gives information about thread, heap, process, radio state, etc. One can capture the screen using DDMS. DDMS can be opened by following the steps given below. In Eclipse, go to the Window menu, go to Open Perspective option, select Other from List, and select DDMS. Before we summarize, go through the quiz section to check your understanding of this lesson. Here is a quick recap of what we learned in this lesson. The architecture of Android operating system is divided into the following sections: Linux kernel, libraries and Android runtime, and application framework. There are 4 basic components of an Android application, namely activity, service, broadcast receiver, and content provider. ADT Bundle is a set of latest Android SDK, Eclipse, and SDK Manager. Android Virtual Device, AVD, or emulator, is a logical device where you can install, run, and test your application on your machine. DDMS is the abbreviation for Dalvik Debug Monitor Server. With this, we come to the end of this lesson.